Hello, ladies and gentlemen, and welcome back to Chapter 14, where we have been talking about plants. Today, instead of talking about structures, we are specifically going to talk about plants in action. This is the first part, and we're going to talk about how plants aren't always what you think about when you think about plants. They aren't always the way that you think. Okay, generally, when we think of a plant, this is what we think of. We think of a pot and a plant sitting in the pot or, in the dirt, and it's just sitting there. The reality is plants are in motion. They don't just sit there. Lots of times we don't think of motion with plants because we don't watch it. About the only time we think of plants moving is like if the wind blows or something. But the reality is plants are generally in motion. Now, the first type of motion is what is called a nastic movement. And this is a movement that is not related to direction in any way, okay, of the stimulus. The movement itself is caused by a change in water pressure. I saw a video with these Venus flytraps, and they said it was an electric current. And sorry to say, there are no electric currents in a plant. In an animal, sure. Plant, no. Okay, so it actually is caused by a change in water pressure. Now, most of you know what a Venus flytrap is. You know it is a plant that actually is able to eat meat, in essence. Insects, little bugs, worms, spiders, etc. Now, the reality is, if you look at the inside of a Venus flytrap, you see these little hairs. Now, there's, from what I've seen, 6 little hairs, 3 on each side. And they're kind of like a booby trap. And if you go and you touch one, nothing happens. But if within 20 seconds the second one gets touched, it automatically closes. And that is caused by the change in the water pressure inside of the cell. It basically wilts and causes the plant to change shape. The way it entices insects is right along the edge here, is it makes a very sweet tasting nectar. So if the insect is very careful and just, kind of walks along the edge, doesn't touch right there, doesn't care about the nectar in the middle, they're fine. They're not going to be eaten by the Venus flytrap. But if they touch those little trigger hairs, they are probably going to be something's meal. Okay? So to see it in action, you could see those little trigger hairs right here. There's, like I said, there's 6 total, 3 on each side. And obviously this one's been open for a little while because it has cobwebs and things. But we have our little fly friend here. Okay, and remember, this is a plant you're watching. Okay, so they're feeding their Venus flytrap. And watch those trigger hairs. They help. Okay, so you see the plant actually changes shape. However, in this scenario, the bug actually is able to escape from the Venus flytrap. So it's not a guarantee, but the plant will open up and try again. Okay, now the second type of movement is called a tropism. Trop actually means to turn in this case. Okay, now a tropism is a movement that has a stimulus that is from a specific direction. It's coming from one place. And the movement is caused by plant hormones causing the plant to grow in unusual ways. And that is what causes the movement. Now, there are different types of tropisms. The first type is probably the type most people are aware of, and that is phototropism. And photo, you know, means light. So this is a movement that's triggered by light. Okay, so you can see you have a potted plant here. It is sitting by the windowsill, and I have the little sunlight over here to indicate this is the direction that the sunlight is coming from. Because between the internal lights and the external sun, it's hard to tell. Now, obviously, this is time lapse. You're not going to see the plant just, do its thing. Most of the videos you're going to see today are time lapse because we don't watch long enough. Okay? So you can see the plant is very obviously bending towards the sunlight. Okay, that is phototropism. It is moving towards the sunlight. Now, the roots of a plant actually move away from light. So that's actually referred to as negative phototropism. Stems and leaves towards the light, roots away from the light. Okay. Now, the next type of movement is called gravitropism, and like you would assume, it is triggered by gravity. Now, generally, again, roots go down, stems and leaves go up. Now, you'll notice this looks black and white, and that is because this is taken in the dark. They didn't want light to influence how the plants moved, because as we just saw, plants move towards light. So they wanted you to see that this has nothing to do with light. This is all happening in the dark. Okay, they put it on its side. You can see the plants are turning. Turn it over. Plants turn over. And then they put it back. Now they're trying to go up again. Okay, so in this case, it very much shows that the plants are directly responsive to gravity. Okay. This I actually forgot to change the top. This is known as thigmotropism. So not gravitropism, this is thigmotropism. That is spelled Thigmo, and then the tropism. I apologize for that. Okay, thigmotropism, not gravitropism. Thigmo, and then tropism. This is a movement that is triggered by touch. A lot of vines you will see have this. Okay, and you can see this vine is actually moving in a regular basis. Okay, you're not used to thinking about plants moving, but this is what it's doing. You just don't watch long enough to find out. And then when it touches, it starts growing around what it touches. Okay, so whenever it comes in contact, it will hold on to it and grow upward. And that's generally to support the plant and keep it upright towards the light. Okay. And again, I apologize. That was thigmotropism, not gravitropism. Okay, this is the fourth kind of tropism, which is hydrotropism. Hydro, of course, means water. And this is movement triggered by the presence of water. If you have a tree planted near a stream, its roots will go towards the stream, and in this case, the roots are going to go towards the water for the bean plant, and I will show you. It's kind of fun to watch slow motion, or I guess I should say time lapse. When you speed it up like this, it almost looks like it's an animal burrowing its way through. Okay, so you can see the roots are definitely going down towards the water. And we'll let the plant grow up a little bit before we stop it. We're not going to watch the whole video. I think they just kept it going long enough to see the whole plant grow for a month. Okay, so you can see the leaves open up. The leaves are constantly in movement. It's not for stretching up for that sunlight while the roots go down. You can still see the roots growing on the left side. If you pay attention, you see more and more roots going down as the plant goes up. Okay, so you get the idea. So plants are constantly in motion, and we will talk more about things that plants are doing next time. Until then.